Hello. Let's talk about kinetic energy. So these cars have kinetic energy because they're moving. Kine is from Greek. It means motion. That's where we get the word cinema, kinematics in physics. These cars are moving. They have energy. Remember, the unit of energy is the joule. That's spelled Joule. So kinetic energy is equal to 1/2 times the mass times the square of the speed. 1/2 mv squared, where I guess v is the first letter of velocity. Velocity is sort of like speed, so 1/2 mv squared. Right, here's some cars coming at me. They all have kinetic energy. So given our definition, well, it's sort of a definition, but it also follows from laws of physics. So if kinetic energy is equal to 1/2 mv squared, kinetic energy is proportional to the square of the speed. So the faster you're going, your kinetic energy is really increasing a lot. I mean, imagine a parabola. You all know what a parabola looks like opening up. That parabolas really increase a lot. Look at these. Look at the McDonald's logo. That's two parabolas opening down. So if you just imagine those on their, oh, that's a lot of kinetic energy there. If you can imagine those parabolas opening up instead of down, you can imagine a graph of kinetic energy. The clouds, notice they're moving, they have kinetic energy. If we're at the top of that building, we have what's called potential energy, which is equal to an object's mass times the acceleration due to gravity times its height. Anyway, kinetic. Well, so once we have this picture, I guess we should talk about potential energy. Well, those clouds have kinetic energy, and if we were at the top of that building, we'd have potential energy. If we were to fall at the top of the building, our potential energy would get converted into kinetic energy. Some of it would be lost to friction with the air, resistance with the air, but most of our potential energy probably, by the time we hit the ground, would be converted into kinetic energy. Energy is conserved. It's one of the great laws of physics. It can either be transformed. Well, imagine we're falling off the top of this building. Our potential energy is getting transformed into kinetic energy, and the way energy gets transformed from one form to another is by work. So the force of gravity is doing work on us as we are falling, and that's transferring energy from the potential form to the kinetic form. So, you know, we could estimate like how fast we would be when we hit the ground. We could estimate our mass, how high the building is. Acceleration due to gravity, we sort of know. Okay, that's all for now, folks.